Okay, in this video we will look at the insulation resistance test, IR test, which is a very common non-destructive test that's employed, commonly used in the industry. Okay, it's the most basic test. Okay, so the purpose of insulation around a conductor is much like that of a pipe carrying water. Okay, and flow of electricity can be more easily understood by a comparison with water flow. So basically, you have conductor carrying the current, and then you have insulation that wraps around the conductor. Okay, so if the insulation has problem, puncture, break, okay, we have electrical leak. Okay, we have leakage of the current leakage increase because of the problem with the insulation, which is similar to water flowing in the pipe. So we have water as the current flowing in the conductor, and then we have the pipe which is the insulation. So if the pipe has puncture, is broken, then we will have water leaking. Okay, same thing for the cable and conductor. Conductor and insulation. We have problem with the insulation. We have leakage current. Okay, so that's the basic idea, the comparison. What is the IR test? You want to test the insulation resistance. Okay, to check the resistance of the insulation. So this is a typical mega test or IR test. Instrument hook up, okay, connection of the instrument to measure the IR. Before it was called, it's also commonly called as mega test. Okay, because mega introduced this type of test. Okay, insulation resistance test. So commonly industry will use mega equipment to test on the IR, to check on the IR. So the connection is this is for a cable. Okay, the conductor is connected to live, and the insulation, wire insulation, is connected to the earth. Okay, so we supply DC voltage, okay, and then we measure the current, and then using the Ohm's law we can get the resistance of the insulation. Okay, so very simple, very basic. However, we must notice that the temperature can cause the insulation resistance value to vary. Okay, so resistance also dependent on the temperature. So when you perform the IR test, you have to take note on the temperature during the measurement as well. As you can see on the top right corner of the screen, the graph, this is the correction factor of the insulation resistance according to the temperature. This is based on IEEE standard 43, which is for the electrical machine. This is 2000, but of course 2013 you should have the same, you'll find the same graph. So you can see here, if you measure at 50 degree, then the value will be different at 30 degree. Okay, the value of resistance. Okay, in the context of a preventive maintenance program, the measurements should be carried out in similar temperature condition, or if this is not possible, should be corrected so that they are expressed in relationship to the reference temperature. Okay, so meaning that for preventive maintenance program, let's say you're working at a factory. Okay, you have to measure the IR, the insulation resistance of the machine. Okay, let's say you perform the IR test every year, or every 6 months, or every 12 months. You perform the IR test after 6 months you perform the IR test, and then after 6 months you continue do this maintenance program. You plot the IR results, you compare if the value maintains or is reducing or not. So make sure that when you compare the IR value for every 6 months, you make the temperature correction, compare at similar temperature conditions, okay, so that you can see that the value is reducing. If it's reducing, means that the machine insulation resistance of the machine is getting weak, okay. For example, as a rough guideline, a 10-degree increase in temperature half the insulation resistance. So it's very, very important to do the temperature correction, okay, the resistance correction due to temperature. So another figure showing how to connect the test equipment to measure IR, to perform the IR test. So in this case, this is 3-core cable. Okay, it's a cable with red, yellow and blue. Okay, red, yellow and blue, 3-phase cable. Okay, so this is the conductor under test. Let's say this is red phase. Okay, so red phase connected to black, and then the other phases connect to the ground as well, connect to the red. Okay, so this is basically measuring the insulation resistance between conductor red and ground. Okay, and then repeat on conductor yellow, ground, conductor blue and ground. So this is the connection for a 3-phases cable to test on the IR. So you will have IR value for red phase, IR value for yellow phase, IR value for blue phase, right? Okay, so this is a connection of insulation resistance measurement on electrical installation. Basically same thing, the resistance, the cable. So you measure by per phase, okay, per phase. Okay, first is the cable 1, red, and then yellow, and then blue. And then this connection for rotating machine, for motor, for generator. If it's delta connected, okay, just take one conductor, and then the other one is connected to ground. If it's Y connected, or you can remove the connection here, make sure you measure the resistance between phases, okay. And then IR test on transformer. So you have low voltage winding, you have high voltage winding, right? So you perform measurement between, okay, this is okay, between high voltage to earth. Okay, you are this connection is to test the insulation resistance for insulation between high voltage winding to ground. So see here, high voltage winding connected to the live. This is the ground connected to the earth. And then if you want to test the insulation between high voltage and low voltage winding, high voltage winding is connected to the live, low voltage winding is connected to the earth. Okay, and then IR test on transformer bushing. Okay, one is connected to the top, the other one is connected to the bottom. Alright, so that's the idea of for connection. Basically, you connect one conductor and the other one is ground. So you are measuring the insulation resistance between these two terminal, and in the middle is the insulation that is to be tested. Alright, so selecting the test voltage, So I think I have shown this before, right, in the previous video, how to choose the voltage. So basically, if you refer to IEEE standard 43-2000, this is the table. Okay, based on the equipment operating voltage. Okay, for example, you have transformer, 11 kV transformer. So 11 kV transformer falls under this column, sorry, this row. Okay, so you can test the transformer, the winding, using this value, right? 2.5 kV to 5 kV VDC, direct current voltage. Okay, this 2500 to 5000 VDC, this is the voltage that you set at the mega, at the IR test set. Okay, you key in 2500 or up to 5000 voltage DC to test, to measure the resistance. Okay, so just follow the standard on the voltage, suitable voltage value for performing the IR test. And then what is the suitable or the acceptable value of the IR test? So basically, if you look at here, insulation resistance, okay, of the test object should be approximately 1 mega ohm for each 1 kV of operating voltage. Okay, with a minimum value of 1 mega ohm. So 1 mega ohm and above, that is a must. And then if it's 1 kV, is 1 kV, it must be 1 mega ohm. If it's 2 kV, the acceptable value of IR must be 2 mega ohm. Okay, for example, a motor rated at 2.4 kV. Okay, we have motor 2.4 kV motor. So the minimum insulation resistance is 2.4 mega ohm. So 2.4 kV motor, we perform IR test on the motor. So the value must be above 2.4 mega ohm for the test to be accepted. Okay, if the value is less than that, means that the insulation is very weak, it's no good. So we have to further investigate or replace the unit. Okay, if it's above 2.4 mega ohm, then the motor is in good condition. The insulation of the motor is in good condition. Okay, in practice, mega ohm readings normally are considerably above this minimum value in new equipment or when the insulation is good condition. So although it says here 2.4 mega ohm for 2.4 kV motor, but usually it will go beyond that. So if the equipment is new or in good condition. Okay, and then polarization index. Before that, the IR test, usually when you connect the equipment to the test set, the IR test, to get the insulation resistance value, it will usually take 1 minute. Okay, 1 minute for the equipment to inject the 5 kV VDC, and then to measure the leakage, to measure the leakage current, and using Ohm's law to get the resistance, usually in 1 minute. The second one is PI, polarization index. Okay, so usually in the industry, we perform both IR and PI. Okay, PI is basically 2 readings of IR. Okay, we perform insulation resistance. We obtain the resistance after 1 minute of measurement, and then we continue inject the voltage for 10 minutes, and then at 10 minutes we take the second IR measurement. Okay, so now we have 2 measurements. One is IR measurement at 1 minute, second is IR measurement at 10 minutes, and then if we get the ratio IR at 10 minutes over IR at 1 minute, and the ratio is basically the polarization index. Okay, 10 minute insulation resistance over the 1 minute value is called the polarization index, and can be used to assess the quality of the insulation. Okay, the reason is this. If you look at the figure here, okay, so this dot here is the IR value, okay, over time. Measurement the IR value taken at 1 minute, IR value taken at 10 minutes. So the idea is, if the IR value stay the same after 10 minutes, then usually indicates that there's a moisture and dirt are present in the insulation, meaning the insulation is contaminated, not good. We have to clean out the insulation, right? But if the insulation resistance increase over time, after 10 minutes is multiply, keep increasing, the insulation keep increasing after 10 minutes, meaning that the insulation is okay, insulation is good. Okay, because over time, if the resistance increase, means that the leakage is reduced. No, the leakage has been reduced. Leakage current is reduced, the resistance increase. But if for 10 minutes the leakage current is still the same, then the resistance will also stay the same. That means that the insulation is contaminated, is dirty, you have to clean out, because moisture and dirt on the insulation will cause leakage current. Alright, so here we have a simple table. You can refer to this table. If the PI value is above 4, then the insulation is excellent. Above 4 means that, for example, this is, let's say for example, 40 mega ohm. This is 10 mega ohm. So 40 divided by 10, you will get 4. PI is 4, so it is excellent. If this is 12, for example, this is 10 mega ohm, then 12 over 10 is 1.2, which is less than 2, then the insulation condition is not good. Alright, so that's the idea why we perform PI, because we want to see if the resistance over time after 10 minutes is still the same or keep increasing. So keep increasing, then it's good. That is the idea of IR and PI. And you can apply this on almost all high voltage equipment: cable, bushing, rotating machine, transformer. Alright, so many things.